All right. It says imagine arranging 3 of the red pressure blocks on your ocean map such that they form a straight line from east of northern Florida to approximately east of North Carolina along the northwest side of the Gulf Stream. Quit clicking your pins. Okay? Now, I had to borrow these little blocks from Miss Kester, and they're all actually the same size. So I just made my stack for red twice as tall as my blue stack. Okay? So it says align the red blocks so that the current can be seen along their bases on the northwest side. They represent warm water. Why are the warm water blocks taller? They're less dense. Warm is less dense. So they take up more volume. Okay? Now minerally arrange 3 blue blocks next to the red blocks along the cold water side of the Gulf Stream. The blue blocks represent the cold water. Now imagine laying a pencil on the middle red block and blue blocks perpendicular to the line with the pencil inclined so that its point is resting on the map. So basically they're telling you to do this. Okay? Like so. Now, please understand that water is going to flow which way? Downhill. So water is going to flow from high to low. Okay? Okay, so the inclined pencil, actually my little sticky note, the inclined pencil represents the sloping sea surface. Remember that water flows downhill. And, take your highlighter, flowing water is acted upon by the Coriolis effect. It says rotate the pencil to the right to simulate the influence of the Coriolis effect and lay the pencil on the blue blocks. Okay, so I'm going to take my little arrow and do the little pencil trick. So it's pointing like this. And they say, all right, let it spin, but it's got to spin to the right due to the Coriolis effect. So which way does my pencil wind up pointing? Okay, and is that consistent with the way that the Gulf Stream is flowing? Okay. So the pencil now points in the direction towards which the water is flowing. This current direction is or is not consistent with the direction of the motion of the Gulf Stream? Is. Okay, so let's highlight is. That's 16. Okay. And again, why does it wind up that way? Because it's going to be turning to the right in the northern hemisphere. So it winds up this way. All right. Red blocks representing the underlying deep column of water, less dense Gulf Stream water, whereas the blue blocks represent the cooler, denser inshore water column. Okay. Now we're going to model warm eddy W1104. Eddy 1104 is this eddy right here. Does everybody see it? Okay, I'm going to move these blocks out of the way. The model shows that the central elevation of the warm eddy ocean surface is what? Higher or lower? Well, let's think. If this eddy is like a local circulation of warm water and it's surrounded by cold water, then is the eddy's surface higher or lower than the surrounding sea?
Higher.
It's higher. Because it's warm water, it's less dense, it takes up more volume. Okay. So the model on 17, the model shows the central elevation of the warm eddy is higher than the surrounding sea surface. Any questions on 17? Use the pencil technique you just applied, analyzing the Gulf Stream to determine that this topographical relief causes surface water to circulate. Okay, again, my sea surface slopes this way. Things are going to, oops, it's about to fall. Things circulate which way? They turn to the right in the northern hemisphere, and turning to the right in the northern hemisphere is going to indicate that this is going to wind up turning clockwise. Yes. Okay. 17 is higher. You see that the warm eddy Remember, the warm eddy is like a little area of warm water surrounded by cold. So the eddy surface is going to be higher than the surrounding seawater. Okay. So it says use the pencil technique you just applied to determine that this topographical relief causes surface water to circulate, and it's circulating which way?
Clockwise.
All right, it's circulating clockwise as viewed from above. Okay, it says now on 19, model the cold eddy C1104 shown on the map east of Georgia by imagining one blue block surrounded by 4 red blocks resting on their bases. Okay, so here's the cold water eddy that they're talking about east of Georgia. And this time we have a cold water eddy surrounded by what?
Hot water.
Warm water. Okay. The model shows that the central elevation of the cold eddy ocean surface is what?
Lower.
Lower. And that should make sense, right? Because it's a cooler area of water. And it takes up less volume, so it's sunk. Okay? All right, turn the page to number 20. We're not doing D, no. Number 20, use the pencil technique again to determine that this topographical relief causes surface water to circulate. Okay.
Clockwise.
If it's going from warm to cold. Okay. It's going to flow.
Clockwise.
Okay. All right. As seen from above. And it's going to flow in towards the cold eddy. Do y'all see that? Because it's flowing down the hill. Okay.